In the vast landscape of web development, the HTTP protocol plays a crucial role in facilitating communication between clients and server. Among the numerous status codes defined by the HTTP standard, the 304 status code holds a distinctive position. In this video, we will delve into every aspect of the HTTP status code 304, exploring its purposes, implementation, implications, and best practices for optimal use. Before we delve into the intricacies of the HTTP 304 status code, it is essential to grasp the fundamental concept of HTTP status codes. These three-digit codes are issued by a server in response to a client's request made to the server. They provide information about the status of the requested resource, allowing the client to understand the outcome of its request. HTTP status codes are categorized into 5 classes, each representing a specific type of response. The classes are as 1 access, which is informational, that request received, continued processing. 2 access, successful, that means the request was successfully received, understood and accepted. 3 access, which means redirection, further action needs to be taken to complete the request. 4xx, which is client error, which means the request contains bad syntax or cannot be fulfilled. 5 access, server error, which means the server failed to fulfill a valid request. The HTTP 304 status code, also known as not modified, is a member of a 3-access redirection class. It indicates that the client's cached copy of the requested resource is still valid and can be used to fulfill the subsequent request without re-downloading the entire resource. The primary purpose of the HTTP 304 status code is to optimize web performance by reducing unnecessary data transfer. When a client sends a conditional GET request and the server determines that the client's cached version is still valid, it responds with a 304 status code, prompting the client to use its cached copy. This process helps in minimizing bandwidth usage and reducing latency. The 304 status code is closely tied to conditional requests, which are HTTP requests that include conditional headers to specify under which conditions the server should fulfill the request. The key conditional headers include if modified since, which specifies the date and time the resource was last modified. The server will only return the resource if it has been modified since this date. If unmodified since, which is the opposite of the if modified since, indicated that the server should only return the resource if it has not been modified since the specified date. If match specifies one or more entity tags, which are E tags, that the resource must match for the server to fulfill the request. If none match, the opposite of if match, indicating the server should only fulfill the request if the E tag does not match the resource's current E tag. When a server receives a conditional GET request and determines that the client's cached copy is still valid, it responds with the HTTP 304 status code. The response typically includes headers such as date indicates the date and time when the response was generated. E tag, a unique identifier for the current version of the resource. Cache control directives for caching mechanism, specifying how the client and intermediary caches should behave. Upon receiving a 304 response, the client knows that it can use its cached copy of the resource. This helps in reducing latency and enhancing the user experience, especially in scenarios where bandwidth is limited. Implementing the HTTP 304 status code effectively can lead to significant server load reduction and bandwidth savings. By avoiding unnecessary data transfer for unchanged resources, both server and client resources are conserved. If you are encountering the HTTP 304 not modified status code, fear not, as we present 5 practical solutions to troubleshoot and resolve these issues. While some problems may be beyond your control on the client side, you can recommend these solutions to ensure a seamless web experience. Start by deleting all browsing data, cookies, and cached information. Clearing your browser's cache removes temporary storage, saving disk space and enhancing performance. Outdated resources in the cache can prevent the display of updated content, making it crucial to acquire a fresh copy from the site's web server. Click on the 3 horizontal dots at the top right corner, navigate to History, and then from History, click Clear Browsing Data. Choose the time range All Time, select Data Types, and click Clear Data. Operating systems store cache files in the domain name system (DNS), impacting host names, IP address, and resource records. Flushing the DNS regularly improves security, prevents tracking, and resolves issues like the HTTP 304 not modified response codes. Enter Chrome /net internals /hash DNS in the address bar. Click clear host cache. If previous methods don't resolve the issue, investigate your server configuration file. Incorrect redirect instructions in the .htaccess file might be the culprit. Disable the .htaccess temporarily, check the site's availability and the 304 status code, and re-enable it if necessary. Browser corruption due to viruses or malware can lead to HTTP 304 not modified issues. Run a malware scan to identify and remove threats. For Google Chrome users on Windows, use the built-in malware scanner and cleanup tool by navigating to Chrome, setting, cleanup. Infected browser extensions may interfere with requests and server communication, causing the HTTP 304 not modified status code. Temporarily disable browser extensions to identify the culprit. Navigate to Settings, then Extensions. Disable each extension by toggling the switches. Optionally, click Remove to delete unused or outdated extensions. By following these 5 methods, you can address HTTP 304 status code issues and ensure a smoother and more reliable web experience for users. Effective use of the 304 status code relies on robust cache management. Implementing cache control headers such as cache control and expires ensures that clients have accurate information about the resource's freshness. Utilizing e-tags allows for more control over resource validation. Servers can generate unique e-tags for resources, enabling precise validation of whether a resource has been modified since the last request. Configuring cache expiration settings involves striking a balance between keeping content fresh and avoiding staleness. Fine-tuning these settings based on the nature of the content and user expectations is crucial for optimal performance. Thank you for watching and subscribe for more videos.